This is note taking guide 4.3 for Math 1. Today we're going to talk about the explicit formula for arithmetic sequences. The first thing we need to decide though is the difference between explicit and recursive, because we're going to ask you throughout this chapter to find the explicit formula and to find the recursive formula. So this definition here at the top is important to kind of keep in mind. Explicit means it's a formula for any term of the sequence depending on the term number. So say you're looking for the third term, you can plug 3 into this formula to find the third term. Say you're looking for the 100th term, you could plug 100 into the formula in order to find the 100th term. So the explicit formula finds every single possible term. The recursive formula, on the other hand, is a formula for the next term depending on the previous term. So say we're looking at a arithmetic sequence and we know the first term is 4, the second term is 6. Well, I can find the third term because I know that the common ratio or the common difference was 2. So I know that I could just find the next term by using the previous term. When we do that, that's called recursive or recursive formula. So when we find the explicit formula, there's actually there's a way to do that. There's a formula to do that. So what we have to know is we have to know the first term. We have to know the common difference. And then this n is the number of term we're looking for. So if I wanted to know the 10th term, then I'm going to put a sub 10, meaning I'm looking for the 10th term, and 10 will get substituted in place of the n. So this is the explicit formula here for arithmetic sequences. So let's see if we can use that formula in order to do some stuff. So on this particular example, this first one, they actually gave us the explicit formula of an arithmetic sequence, and they asked us to fill out the table for the first, second, third, fourth, fifth, and 100th term. So really all we have to do on a problem like this is substitute our numbers in. So the term is our n value. So here's n equals 1, here n equals 2, and I just need to substitute it in. So if I'm looking for the first term, see how I substituted that 1 in place of n? I would do 6 plus 2 times 1 minus 1. And I would just plug that in my calculator, so it will do it right for me. But 1 minus 1 is 0. 0 times 2 is 0. So all of that is 0. So my answer is just going to be 6. So the first term is 6, the value of the first term. Okay, if I want to find the second term, then I'm going to put 2 in place of the n. So I'll have 6 plus 2 times 2 minus 1. And I can just punch that in my calculator exactly how it appears with the parentheses around it, and it will give me that solution. I'm just going to do it in order of operations though. So 2 minus 1 is 1. 1 times 2 is 2. 6 plus 2 is 8. So 8 is my second term. If I want to find my third term, then I'm substituting 3 in. So 6 plus 2 times 3 minus 1. Plug it in your calculator, get your third term out. So this is 2. 2 times 2 is 4. 4 plus 6 is 10. Now, by now, you should be able to see a pattern. This goes 6, it goes 8, it goes 10. The next one's going to be 12. The next one's going to be 14, which is easy to do once you know the pattern. You can find it, but are you going to want to write all of these out up to the 100th term? You're not going to want to, which is why we found that formula in the first place. We don't want to have to write out 100 terms to find the 100th term's value. So the formula helps a lot when we want to go big. So we're going to find the 100th term now by substituting in 100. So 6 plus 2 times 100 minus 1. 100 minus 1 is 99. So 99 times 2 is 198. 198 plus 6 is 204. So the 100th term of this sequence is 204. So again, what we're doing is we just take the term and we substitute it in place of the n, and that gives us the value at that term's number. All right, so same problem here. Another arithmetic sequence. We have been given the explicit formula, so we're just going to substitute our values in, solve, and then if I can find the pattern quickly here, I'm going to use my pattern to find these ones and then just substitute that 100 in again to do it. So my first term is found by substituting 1 in place of the n. So 1 minus 1. That's going to be 0. 0 times 6 is 0, so a big fat 0 there, and I get negative 2 for my value that I substituted in for the first term. So the first term is 2. Okay, now I'm going to find my second term. My second term is negative 2 plus 6 times 2 minus 1. 2 minus 1 is 1. 1 times 6 is 6. Negative 2 plus 6 is 4. So I know this is arithmetic, so if I know this pattern to get from here to here, I don't actually need to keep substituting in. I can just use that pattern. That pattern looks like a plus 6 to me, which would make sense because here's my common difference right here. It tells me to add 6 to my pattern. So my next number is going to be 10. Because I added 6 to the 4. My next number is going to be 16 because I added 6 to the 10. My next number is going to be 22 because I added 6 to the 16. But that 100th term, I don't want to do 100 of those to figure that out. So I'm going to come back over and I'm going to substitute it into my formula. So to find the 100th term, it will be negative 2 plus 6 times 100 minus 1. 100 minus 1 is 99. My times 99 by 6, and then add a negative 2 to it. So I get 592. So the 100th term of this arithmetic sequence is 592. All right, next example. It says find the next 2 terms in the sequence, and then it says write the explicit formula for the sequence. So, how do I get from 25 to 20, from 20 to 15, from 15 to 10? This is a subtract 5 or a add a negative 5. So negative 5 is going to be my common difference. I can find the next 2 terms because I'm just subtracting 5 from them. So 10 minus 5 is 10, or is 5, and 5 minus 5 is 0. So my next 2 terms were quite easy to find. Now though, I need to go back and I need to look at that original formula to find my explicit formula. So it's a sub n equals a1 plus the common difference times n minus 1. Alright, so what do I need? I need a1 and I need the common difference because the n is the variable that we always just keep in there. So a1 is my first term. My first term is 25. The common difference is a negative 5, so I'm going to put minus 5 here instead of plus 5, and then it would be n minus 1 still. So if I wanted to find the, say, 100th term like it asked me to on the instructions, I would go a sub 100 equals 25 minus 5 times 100 minus 1. And I would just plug that in my calculator. I can do that exactly the way it's written, or I can go by order of operations. So I would start back here. 100 minus 1 is 99. 99 times a negative 5 is a negative 495. And then a negative 495 plus 25 is a negative 470. Which makes sense, you guys, right? Because if I'm already at 0, my next term would be negative 5, then negative 10. And I have to get all the way, 100 terms from there. So I'm definitely going to be negative. So if you're wondering, was I right? Well, kind of check it out. See if it makes sense. And it does make sense that you're going negative that direction. All right, one more example where we're doing the same thing here. We're going to find the next 2 terms. Then we're going to write our explicit formula for that. So the first thing I have to do is figure out how I get from here to here to here. So negative 22, I'm going to be subtracting or adding a negative number in this case because I'm going smaller or further away from the 0 on the number line. So it looks like it's going to be a -7. And then a -7. So let's do 36 minus 7. So a -36 minus 7 is a -43. And then a -43 minus 7 is a -50. So we're going to write our explicit formula. Our explicit formula, again, if we go and just grab it from the original, it's a sub n equals a1 plus the common difference times n minus 1. I know my a1 value, it's -22. I know my common difference is -7. And you don't necessarily have to have that plus sign there, but I wrote it, so I'm just going to leave it. And then times n minus 1. I'm finding the 100th term, so I'm going to find a sub 100. So -22 plus a -7 times 100 minus 1. Again, just going to plug that in on your calculator so that you can get that correct. I'm going to start at the back and do 100 minus 1 is 99. 91 times a -7 is -693. And then add that with a -22 is a -715. So the 100th term is -715. All right, hopefully you got that. Good luck with your assignment today on explicit formulas for arithmetic sequences. Thanks for watching, guys.